Guys, welcome to this session. We're gonna have a brief introduction about data structure and algorithms. Like we know, DSA, I would say in this case we call it DSA, is a very common popular tool to know how for a software developer, and it's getting so much wave because people are trying to understand how the software engineering principles was derived from. So, without further ado, let's talk about the main objective, like how we're going to like assess this session. Um, First of all, we have to understand we're going to understand the fundamentals of DSA concepts and the underlying principles. Then we recognize the significance, the relevance of DSA in designing efficient software, and then we also comprehend the concept of algorithms and DSA and data structures based on real life scenarios, which is very, very, very intuitive and practical. So we'll make some life something they can relate to, and then you'll be able to like have a good understanding about DSA. We also like apply the knowledge of asymptotic complexity, which is like an evaluation matrix for to be able to like gauge whether a particular algorithm is efficient or not. We see that, and then the process, sure, we will develop a very congent problem solving skills. Then we'll be able to be able to like think logically and critically when we have a problem in front of us. So without further ado, let's begin the main content. Like we know about the background of GSA, it's like the blueprint of the digital world. If you think about it, the world basically in the digital world is basically dominated by software applications. And so when you think about it that way, and the basics of those, the core basics of building those complex applications are concept derived from DSA. So if you think about it that way, you see feel like DSA is like a blueprint of digital world. So basically like DSA is also like knowledge of DSA can help you to build complex applications. Like I said, it's also like a mental gym, like a weight trip. You just when you go into when you know the concept of DSA, the design principles, it kind of gives you revives you, gives you a little bit of strength to be able to like think dynamically, think logically, which is very important. And we also know like DSA is a skill that's actually is top sought out for tech companies and big tech companies because they want you it's not about you writing code, it's about you writing code efficiently, like you want to do at a particular time. So that's very, very that's a very good plus. So let's start with data structures. So what are data structures? Basically, when I was kind of new to programming, I always read blogs about data structures. They make it feel like it's kind of a complex stuff. But basically, just think about data structures like just a bookshelf of books. Like that's it basically. Like it's just something that keeps something like acts as a container basically, and is structured in a particular way. Like the bookshelves, you say, or they will say a particular books are gonna be here for a particular field. Just what data structures are all about. It's kind of you can easily be able to access a book quickly and all of that based on how the structure is like basically. We have other types of data structures. We have arrays, we have stacks, we have queues. Arrays are the popular ones, and they have a constant time operation. But we'll talk about what is constant time operation in the next slides. So data structures and algorithms. Let's go to algorithms now. What are algorithms? Algorithms are basically like now think about it, the bookshelf, right? Now you want to like access a book. Now the pattern that just that data structure has imbibed in itself. The algorithm now follows that procedure to be able to like find something, be able to like do a particular operation. It's just a set of recipe recipe to be able to like do a particular activity. That's what basically like algorithms are. In this example now, algorithm will be like you trying to like walk to the library and then be able to like find a particular book. So we have many types of algorithms. We have search, we have sorting, we have binary search, and basically like algorithms are more about like being efficient. I will talk about it in the next slide. Being efficient. In that aspect, asymptotic complexity. This is very important section of DSA, and because algorithms are cool, right? They are cool. They are recipe to carry a particular operation and then being able to like resolve it and being able to like have a definite answer. guys. But when you think about it, if an algorithm takes so much time to run, it's not efficient, right? It's not efficient because it does not make any sense and it takes all the time to run. So algorithms now they need like a evaluation matrix to be able to like categorize how efficient they are, and this is where associative complexity comes in. And then and a very big example of one we use for is big O notation. So it's very important. So it compares us now to be able to like write efficient code, be able to like simulate better performances of our algorithms. So we have many types of the complexities. We call them time complexities and storage complexities. We have constant time. Constant time is basically like it takes the same amount of time like accessing an item in an array. It's a constant time. The linear time is one that grows linearly. So something like searching. That's like a for loop now that goes to a same element. So it's a big O of n, like you can see on the screen. So let's talk about like the linear current complexity. Like I said earlier on, it's just basically like going through traversing an array. That's a good example of linear time complexity. Basically, like the big O of n. Big O of n is the number of the elements. So if these elements are like the norm is like I think six or seven. So the big O of n the big O of n is gonna be six. Yeah. So and the algorithm complexity also is kind of is faster than the big O of n because it uses like a half. It's kind of sorted, so it halves the data, the input size. So the linear time does everything, like it goes to every item in the array, but the binary search algorithm, what it does is basically like it halves the once it goes to a particular array, it halves it. Basically when you're trying to find something, it halves it and then reduce the input size. So basically like it's a faster time complexity than linear time. We also have quadratic complexity. This one involves like when the time to run the algorithm is increases like it's n squared. So that's n squared. Like it's not n against n squared. So a typical example is like a for loop. In a for loop, so it's going to a particular element and going to the same element again. So if you do I can see the slide. Like I see whether I did some n raised power 2 times and then they drop the lowest degree and all that. And something about the big O notation is that very important. It cares more about the highest the worst case scenario. Like it does not care about anything that would not gonna like affect it. So in this example now, the inner loop and there's another loop again. You can see that, but it does not consider that one because the second part consider only the first part because the first part is the worst case scenario. So that's bit about quadratic big notation. So if you create a size, we just do create a size. So what is the one-time complexity of this provided snippet? You can take a minute and just check whether you could derive the concept, know what this is all about. Okay, next slide, I'll get the answer. The answer is cubic time. You can see on the other slide, cubic time, because you can see that it's a three inner loops, and then the other loop is just a single. And like I said, big notation does not consider the smaller ones, so it considers the bigger part. So we're done with this. To this session, we talked about the background of DSA, emphasize on like the pros, why we need to like know it, why it's kind of a good mental strength for us, why it develops our problem solving capacity. We also like talked about data structures and algorithms, to give life examples. Which can relate to, and I'm sure like we are able to like understand how the concept, like how basically the concept of all these things so minute that you can be able to like derive very 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 cogent ideas of how things really work in the digital space. Then we talked about associative complexity, which was it was very intuitive, like being able to an algorithm being efficient is very important than just an algorithm that just runs just for no reason for a long time. We did some exercise, and then hopefully we have a good grasp about the concept of DSA. So thank you.